Okay, so we started the last presentation for today. Alexander Wolf is presenting the support strategies for robocasting in ceramic additive manufacturing for building construction. And after this presentation, we'll go to Design Institute, okay, for visiting the data lab and seeing how Dunia and Tatiana are going with their experience. Okay. Thank you.
Okay, so today I'm talking a bit about support strategies for robocasting. It's a very theoretical thing I brought to you because we have certain issues in the institute, financial issue and technical issue, and I wasn't yet able to even print. So I did a lot of preparation for my dissertation, which will be a cumulative one, so I made up first a nice storyline, and the good thing about the cumulative dissertation is that in the end I can just wrap up some papers wrote, write an introduction, write a conclusion, and this will be the framework of the whole dissertation. And because I wasn't able to print yet, I started with basic research, and in January, I think it was, I published the first paper called Additive Manufacturing of Clay and Ceramic Building Components. And this was so kind of the thing that brought me into contact with Bruno, with Paulo, and with David, because I just wrote you an email and say, hey, you have some nice projects. Can I have the image rights to just publish them in the review? And so, yeah, so that's how we got into the first contact. So phase 1 of 5 or phase 1 of 6 for me is basically done. I have reviewed certain projects on additive manufactured ceramics. I also reviewed some clay projects, like, you know, the WASP projects in Italy, because the difference is not that big, because it's the same technique almost. The biggest difference is that they don't burn it afterwards, and they just let it dry out. And also what I reviewed was, I called it robo-stacking. You all know those Kamatsu-Kola research, where the robots stack the bricks to for example, the winery, or they also were in Venice on the Biennale. So this is phase 1, this is done for me. And the next step for me will be to explore a bit more of the technology. And from what I know so far from the review, there's 2 things that I want to research to make the technology kind of market ready, because the one thing is the support strategies, and the other thing is the surface finishing, because we have this process doesn't provide like a powder bed and like another AM technologies. And so if we have some cavities or overhangs, we need to somehow give them a support. And the other thing is, we all know the certain look of AM objects. Doesn't matter which technology, you always have this little wobbly surfaces. And to fully integrate an additive manufactured brick in a visible piece of facade, you need to know how to make it kind of even, to flatten this, or how you can treat this surface so it's not too obvious that it is a 3D printed brick, if you don't want to have it. So we've seen the works of Isabel and James, and they use really this wobbly thing as a design feature. But if you consider this 3D printing as a technology to get more freedom of design without showing your process, then you need some ideas to manage the surface finishing. And as soon as I know how this even works, I want to carry out a little case study. It's called the nesting brick. I want to build habitats for endangered birds, bees, bats, and whatever lives on a plot of land where what might be a reason that there is a plot of land you can build on, because there's an endangered species and you have to integrate them. And the last thing is approaches for the implementation of AM brick manufacturing processes. But after last week's PhD seminar, I will kill this topic because they all told me it's too much, it's too much, it's too much. But basically, Uli wanted me to kill the surface finishing. Nope, I won't do that. I've slept over it for several nights. I won't do that. I'll kill the last one. So just you know. I'm going not to do the approaches on the implementation, because that's a thing a brick manufacturer can do who wants to squeeze money out of what I'm doing. For me, I want my dissertation to be kind of a handbook. Just if you're somebody and you want to implement it in your brick facility, this should work as a handbook to just see what has been done, how is it done, and the case study is to how the support strategies and surface finishing things could be applied on something. To get a bit further into this, I was asked for research questions, and I had to really formulate those research questions because at least my colleagues know me. I'm an architect. I'm good in storytelling, but when it comes to serious research, I'm a bit clumsy. And so I was forced to ask myself all those questions and or to bring it down to one very sentence. And for the support strategies, is it how can the geometric freedom of AM ceramic objects be improved by optimizing support structures? For the surface finishing, it's which methods of surface finishing are suitable for AM ceramic objects, and how could these affect the integration of printed objects in buildings? It's a bit longer sentence. But the overall question for the exploring technology, which measures have to be taken to improve the process with regards to the needs of the construction industry? Also, I defined some boundary conditions for what I do. And you see on the left side, you see the intended papers or the papers that still exist. And this graphic means to just have a look on what's the difference between the papers and what they have in common. So they all have in common, it's building construction and it's additive manufacturing, that's for sure. When it comes to the product, the last papers will be about ceramics. First papers, as I already explained, will also cover the clay topic to just give it a holistic approach. Also, the first paper was about various processes, and for what I want to do is to just do it in robocasting, so the technique we all use with our Lutum or WASP devices. So just a liquid deposition modeling process. Same, or again, material. In the review, there were various materials mentioned. I want to have a typecasted clay. So I have this industry partner, and I need some formula of that clay, from my point of view, that everybody who wants to even check what I did there, he needs to know with which material or which technology I did it. So I want to have a typecasted clay, which is the same for some typecasted clays that are all the same for all my projects. So like 2 to 5 different mixtures, maybe some yellow, some brownish, some red clay to test it out. And also, the type of work, as I mentioned, the first were reviews. Was one review. The next 2 papers should be a series of experiments, and the last one a case study and about the approaches for implementation. We don't talk anymore, but I didn't come to erase it from the presentation. And to get a bit closer on the support strategy thing, usually this workshop should happen in, I think it was January, and for myself, I intended it as kind of a job interview, because after that, I wanted to ask Bruno if they have time and space for me and if I could visit for like 3 months or something. I couldn't ask in January, so I just wrote an email and he said, yeah, that's a good idea. And I applied for a scholarship. I don't have an answer yet if they would fund me for this, but if this works out and I come here, I want to show you what I intend to do here in terms of the experiments, because because I think the support strategies would be a closed topic, which could be worked out within the 3 months, so something like this. And I also had to define some boundary conditions for this paper again. So either I will work with a form-free Lutum device, or maybe in our case it's an ABB 6650 with a form-free quad extruder. I guess you are still you are also installing form-free extruders to your robot arms as soon as possible. I talked about the type-casted clay. Also, the material for supports should be, from what I hope to do, is to do it with cellulose. That's why I'm pretty keen on the talk that Dunja and Tatjana are giving right after I'm finished. I also have the idea to try it with cardboard, and EPS or XPS foam could be also an idea to use them as a support material. The specimen size would be approximately 10 by 10 by 10, maybe 20 by 20 by 20. So something handy where I can carry out a lot of experiments. So I can have 3 to 5 specimens of every experiment, and just to compare them to each other. Printing parameters, I guess nozzle diameter will be something around 3 to 5 millimeters, layer height 2 to 4 millimeters. And we need to dry it. I don't know how long to dry it and at which temperature or humidity, but we have to figure that out. So I can provide all this info for maybe a peer review of my work later. And what I want to do is to first get to know what are the limits of the process. Because if we have, for example, the bridging, the question is, what is the biggest possible span for a bridge that is hanging mid-air? Because as long as the bridge itself works out, there will be no need for support. But at some certain point, we will need the support. And also, how far is the bridging ability influenced by layer height and/or printing direction? Another question for support is, what is the maximum angle for overhang, and how does this apply for an arc geometry or a dome? And how far is this influenced by layer height? It is, I know from FDM printing, the smaller your layer, the more it tends to give it a bigger angle for overhang. But I don't have any fixed values for the robocasting yet. And I just want to figure that out first. And the third thing where the support is common to use is the distortion. So you have something, you print something, it dries out, and by that it shrinks, or maybe it has a certain geometry that tends to distortion, and then you fire it again. So maybe it shrinks a bit more and even distorts a bit more. And you can counter this, or maybe can counter this with a support material. And so I have certain ideas to just to counteract. First idea is the very simple idea of leaving just an interface layer out. That's what's pretty common in FDM printing. So you just wait for a moment and then you print over it, and there's a little gap and you can break it out afterwards. Which will only work for the bridging and the overhanging thing. Also, an idea could be to have just a reduced interface layer to, even though break it out, but to have a bit more resistance when you break it out, which would work out for all of the topics. Then the printed support, the printed clay support with a printed interface layer, maybe from paper. So we have some interface layer that just burns out in the oven, and we can just take out the support structure. Another idea could be a fully printed paper support, but I'm not sure. The paper takes very long to dry, and I think the process won't work out, but I want to dry. And the last two ideas is just a placed interface layer or a placed support. So I just can stop at a certain Z height and just throw in a piece of cardboard or something, and then I'll let the printer do the rest of the job, and hope that it worked out. Could be an idea too. And And finally, no. There's a page missing. The evaluation is missing. Action. No. Yep. Maybe I can just improvise this. The question is, what do I want to know, or how do I want to evaluate this whole thing? So one question for me would be, how easy was it even? The first question is, did the thing work? Did I get out a proper geometry in the end? Second question would be, how is the surface quality? So if I take out the support, do I have a wobbly surface? Do I have a flat surface? Does it work out, or does, question of visual quality. Third question. I'm not sure. Is it able to? Am I able to recycle my support? So, for example, if I just use it as clay and I break it out before burning it, I can always make it wet again and use it as a material again, so I don't have any waste. If I burn it, then I only will be able to shred it afterwards and put it into the clay mixture as a chamot. We say chamot in German. So that could be an idea too. I'm sure I'm just missing one point or something, but the presentation seems to just miss a page. So the number 11 is out there. Yeah, so that's pretty much it from my side. And I'd be open for questions now. Thank you.
Great. Sorry, I don't have a microphone with me. You can
just repeat them.
Yeah, thanks for the presentation. I have the last slide. So you showed on, I think, slide 11 then?
No, you won't see 11.
So today we learned a lot about materials. Do you see, or also maybe you mentioned about the Tatiana technique would be feasible to support for you? Because afterwards you burn your stuff and you can just burn off the Tatiana's stuff.
Could be an opportunity. So he asked if the things Tatiana was showing about chenine and paper and cellulose printing could be an opportunity to be a support material too. Yeah, I consider that, and that's the reason I want to also get here, because here is the knowledge for as well paper as ceramic printing. And I don't know if it works as an interface. Maybe it even dries out faster than pure cellulose mixture. And then maybe those things with a fully printed paper support could be possible too. But I doubt that it will work with just a cellulose water mixture.
I can add here one thing that I tried in our master thesis. This is mixing clay with the cellulose. So it's improves behavior on first stage after going to at least when it's drying. So can improve the performance for printing certain angles for and then of course since it's dry, it's easier then to hold that shape and then take it to the clink and to the final baking stage.
Okay. I think at some point you wrote a series something intuitive is happening with your printing technique. If you need a paper extruder on one rope down, you need spot and switch over the state and the other rope down. If I am to extruder that one rope down.
Yeah, I guess collaborative robot arms is a pretty tough task for that, but even just a dual extruder will do. So it just can hook up two extruders to one arm and have a defined offset between the nozzles. I hope this is enough.
Thank you.
Any other question? If you come, I have a challenge, which it is only to print in clay. So, as you say, use clay as a support material. We have done some tests with that, and what we do is we define the printing path and correlate that with the retraction direction. They will not be connected. The part that want to be printed is what we use as support. And if you leave some space in between, just a few spots just to help to hold, it works perfectly well, or at least it will work well. And then you don't need to be changing that we have two what arms. But what is interesting, really relate with what David was showing, because you're printing the path for behavior, for kinematic behavior of your elements. So here is the same thing: is how they will move, or how the piece of clay will move. In 1, 2, 3, 4 hours until they start drying, they will move and you get another position shape. And that allows us also to detach the part we're printing as being the positive and negative elements. So
could be an idea too, to have something that removes by itself. Yeah,
we need someone that's trying to take the experiment a little bit further. If that works for other materials, we'll be able of doing anything else.
Yeah, and the thing is, I just want to kind of document things, because one of the worst findings of the review was there is quite a lot of things that have been done, but a lot of things lack on documentation. And there are not so many papers that I really could review, and a lot of my sources are websites and are in newspapers, newspapers, and it's just a small article. And I was always like, how did they even do it, and what was clay and so on? So I have the task for me as myself to just to have whoever comes after me to leave something that's well documented for the topic. So that's the reason I want to do this as a paper. And I know that there are certain techniques that won't work out so well, but I want to at least try them out once, just to write down, don't try that, try this one. So
I'm one of those guilty of not writing down properly already. I will talk a little bit about this in the. But I should write it down. I guess one is also to mention that there's two things to consider. One is the printing support, but also in the oven itself. Because if you would take out the support before in the oven, it will.
Yeah, I have to double check everything of this. So there was a much more bigger table that showed the green state and the dry state and the current state, and I just said, okay, we'll make it smaller. And but I want to try this in every stage to just see, and maybe a paper support. This is self-burning in the oven, could be an idea too. So yeah, we'll see how far this gets. So David.
I've seen that it's not only that the burn of the support, it's also that it starts to become more plastic, and it's also starting to become the exposure forces. So we found some of our pieces, we actually have to basically put it inside of a northern clay piece so that it has more consistency in the temperature in one side and then goes to the other. That creates tension. As if you don't those capabilities, and they start to become very plastic, there's those, you might actually get one in the oven as well. So I think for me, in addition to this, I think a critical component is the drying process. And mostly an active drying process, which I don't think is really using either heat gun or fire to purge as you're printing. But at the moment, they're sort of sterilized and we are framing the same way that the craftsman you did it for basically coiling or something that is manual. But I think the power of the 3D printing is to actually design a channel in the structure. So the moisture to match through it, right? And you can potentially have an active system that is actually allowing to basically increase the rigidity of the clay as you're building it to increase the capability for coordinates. Or potentially have an active system in the temperature in air So then you can reach with other products. In that order, the total might be super, super interesting. But there's so much shrinkage, it's so much, and it's shrinkage that is not homogeneous, right? So that is really, I know you're putting I know artists have used that as a way to create further complexity, right? Further deformations. So in our case, we either increase the versatility or we actually use a design feature that combine into a field. Leave that right. But I was going.
I will definitely consider that. Or I hope to remember this comment when the first one comes out the oven and it's just broke down. Okay, so
Any comment or? No. So I think we can close for now. Thank you, Alex.
thank you.
As well.